Everybody. I am Kathy Grise, Senior Program Director for IEEE Future Directions. I am very excited to have you all join today's webinar on trust in securing the Internet of Things. As the Internet of Things continues to expand its footprint across industries and infrastructures, trust and security have emerged as critical pillars for its sustainable growth. Join us today for the roundtable organized by IEEE Future Directions. Our distinguished experts will address the evolving challenges and innovations in IoT security, from the role of harmonized international standards to the dual-edged impact of AI in IoT ecosystems and the implementation of zero trust principles in a hyper-connected world. The roundtable will provide the opportunity for Q&A and discussion, offering you the chance to dive deeper into the future of securing our connected environments. I want to extend a thank you to our organizer, Anastassia Gharib. I'd like to then welcome Dr. Eman Hammad to speak first. Dr. Eman Hammad is a cybersecurity expert specializing in large-scale network, critical infrastructures, and complex systems. I will turn it over to you. Thank you.
Howdy. I hope everybody's doing well. Let me just share my screen. Thank you so much for the introduction, Kathy. Thank you, Anastassia, and fellow panelists for the opportunity to talk about this today. What I will start with is just to motivate the discussion a little bit, and then I'm not going to dive into solutions or problems. We'll make that more of a discussion. Let me just maximize my screen. Okay. All right. I hope everybody can see my screen. So right now I'm an assistant professor with Texas A&M University in College Station. I've been working with technology industry and academia for 2+ decades. But as part of my career path, I was trained in electrical and computer engineering, and I got to work with cybersecurity as a natural progression of when you build things, you want to make sure that things are secure. And this is why we're here today, because not everything is secure, and security is a moving target. So most recently, in the past few quarters, we have been seeing a change in how IoT devices are targeted or used as part of other attacks. If nobody knows what Mirai attack is, Mirai is something that happened a couple of years ago where an adversary was able to hijack control of many IoT devices, consumer devices, surveillance cameras, etc. And then on signal, they were used to instigate a distributed denial of service against chosen targets. So since Mirai happened, we know some of the techniques that Mirai used, but attacks that use similar techniques to Mirai continue to exist today. And this is evident from what I will talk about next, which is the trends in distributed denial of service. So Mirai botnet variants still exist, and I work with a collaborator in Michigan. It's the Merit Networks, which employs a large-scale network telescope. And network telescope is an infrastructure that tries to continuously sense what's happening on the internet. So they have some IP addresses that are not used, and they are able to listen. And they also have a technology called HoneyNet. And HoneyNet is similar to honeypot, a technology that you try to lure attackers to interact with a little bit so that you learn more about what the attacker's intent are and strategies and techniques, etc. So with working with Merit, we were able to get to do some analysis over the data that's collected, and we pretty much still see Mirai botnet variants and techniques prevalent until today. Another thing that's happening is in the 5G transition, we're looking into narrowband IoT devices and IoT devices that are, especially those that are field deployed, to be connected directly to via wireless connectivity. And this is facilitated using eSIM, which is the module that authenticates and onboards the device into the network. So most recently, eSIM attacks, eSIM vulnerabilities have been more common, and they have been exploited actively. And this exposes billions, possibly billions of IoT devices, if that's the projected type of connectivity. Common techniques and tactics that are observed are mainly supply chain attacks and using IoT devices as part of other attacks, which are distributed denial of service. Now, if we shift to talk about distributed denial of service, and that's where you try to overwhelm the target. So let's say the target is the web server of a certain vendor that's critical for a function. Let's say Amazon services, right? So what happens is you need to inflict a very high volume of requests against that service provider, so it's such that the service provider is not able to provide the service for those who really want the service. So distributed denial of service is tricky to protect against, but service level providers such as Cloudflare has been successful in mitigating some of those attacks. To give you an idea about the scale and how the scale has been trending upwards when it comes to distributed denial of service, we're talking about record size of the amount of traffic that is being generated by those so many devices against the target. So earlier in 2024, we were talking about, there was a report about 1.6 trillion bits per second. Then we have this grow to 5.6 Tbps, and most recently in 2025, this grew to 7.3. So this trend is going upwards, and this is what we describe as hypervolumetric distributed denial of service. Cloudflare also reports that the attacks that are larger than 1 terabit per second increased by 1,885% in quarter 4 of 2024. Now, behind the scene, I challenge you to think about why this is happening. And AI should be part of your thinking by now. Also, what we have observed is, or what has been reported is those distributed denial of service attacks, they're combining multiple threat vectors in conducting the attack. So they're increasing the volume, they're using multiple protocols, they're using applications. And when it comes to the IoT devices that are used as part of the distributed denial of service, it has been reported that this has grown as well in terms of size and power. So how many IoT devices are employed and how much traffic is actually generated by each IoT device. Now we get to talk about this from AI/IoT security perspective. And here I'm going to focus on the offensive part with the hope that my fellow panelists will cover the defense, and I'll chime in on the defense as well because we do research there. So what we have been observing and everybody has been observing is the use of AI for automated exploitation. So right now, generative AI has been noted to be used in generating malware, and generating workflows to actually do the reconnaissance and the research and the open source intelligence to facilitate such attacks. Also, AI has been used by adversarial persistent threat groups to conduct what is called adaptive attacks. So they will start with a simple attack vector. They will try to sense what the defenses are, and then proactively increase or expand their tool set as they go through the attack. Previously, this was done by skillful adversary humans, but now parts of this is being done via AI. Also, behavioral analysis. I hope none of you have fallen victim to a scam, but if you are noticing the phishing that you receive, the email phishing and the social engineering things that you receive or see over the internet. Those had advanced pretty aggressively most recently, and that is in part because of the use of AI in trying to do some analysis of both the devices and the people interacting with the devices. Another very, very, very important trend that's happening right now is AI against AI or algorithms against algorithms. So what's happening is you target the AI-based defenses. So if you have an anomaly detection, it depends on an AI model. How can adversaries jeopardize the AI model to drive false negatives or false positives, etc., right? Okay, so with that in mind as setting the stage, I'd like to share some of the most recent frameworks. So what you see on the left side is the NIST trustworthiness framework for AI. So this can be discussed for hours, but it maps to a trustworthiness frameworks for OT, for operational technology, critical infrastructure, etc. What you see here is when we build an AI system, whether it's part of operations that utilizes IoT or onboard the IoT in the shape of tiny ML, you want those AI models and the ecosystem around them to be trustworthy. And trustworthy is a very hard thing to achieve because you have to break it down to things that you can measure and you can actually implement. So in NIST effort has identified those categories that you see on my slide. So they said this should be safe. And by safe, you can collect measurements about the decision that are made by the AI model that they do not violate the safety constraints. Secure and resilient. So you have multiple layers, and I'll talk in the next slides about the multiple layers. A general way of looking at an AI ecosystem with if it's implemented in an IoT system or otherwise. But then you can implement some of the security basic hygiene on the data layer, on the device layer. And when you build an architecture, you have to consider the elements in that architecture that allows you to be resilient. And resilience is another very exciting topic for me. I'm passionate about building systems that are resilient by design, but resilience means that you are able to build functions or capabilities that allow the system to anticipate, expect unpleasant or uncertain scenarios, be able to withstand and absorb if something happens that was not planned, and then adapt during that disruption and recover after the disruption has ended or has been neutralized. Also, when it comes to AI, there has been a push to use models that are more explainable or at least interpretable. This is a very controversial topic because there is a balance between the black box of some of the models that gives them the advantage, but the explainability is something that's pushes you to use other models that are not necessarily the ones that are more powerful. So it's a debate. But at the end, the point is, if you're not able to know how a decision has been made, or at least some articulation of the basis or the evidence behind a certain decision, it's very hard to distinguish between a decision that is valid and something that has been instigated by a threat actor, for example, right? Privacy enhanced. So that's another topic that comes up often in national security, public safety, and other domains. Is where do you draw the line between sharing more information so that the models are able to take decisions that are more granular versus protecting the privacy and still be able to function within the decision-making framework. Fairness is also a topic that focuses on what you feed the model and the model parameters and fine-tuning, where you are always able to actuate if there will be some shift that's happening over time, or the data set is balanced, etc. So we can talk about these things all day long. The thing with fairness is, in general, we have a struggle with quality data sets. and that's part of the bias that is introduced into the models. But we can discuss further. Then accountable and transparent. So the models or the process through which the models are trained are put whether offline or online, and they continue to be part of the ecosystem. What is the accountability structure, and what's the transparency when something goes wrong? Where does it go? Reliability and validity of the AI models and the decision-making relying on AI, especially if it's part of a closed loop. It's a topic that again requires some explainability, some audit trail, etc. On the right side, what you see is the risk management framework also from NIST around AI. So again, you see something that we always talk about in cybersecurity. You always have to look at the technology. You have to look at the people, whether they are using the technology as a user or as an administrator or as an engineer. And then the process that connects the technologies together and the peoples with the technologies. And here, what you see on the outer circle is the life cycle of an AI model, where it starts from the plan and design, through the collection of the data, through the use of the model verification, and it's a loop that needs to be ongoing. In the inner circle, the middle circle, it's the categories that combine some of those things on the outer circle, and in the center, it's people and planet. Everything that we do will impact is for the purpose that will serve people and planet in some capacity. All right, this is to expand on the idea of resilience. So trust by part is when you build a system that's resilient, that increases the trust over the resilience. And this is from NIST, and this is something that I rely on when I do research. Those are the different pillars that you can work with as you build a system that's more resilient. Now we get to the IoT. So IoT, the Internet of Things, now everything is a thing. So I'm teaching a course this semester, which is a new course on IoT. And I asked the question, give me an example of an IoT device. And I love the answer when somebody said a plane. Yes, a plane is an IoT. Anything that's equipped with sensors and is connected will be a thing under the umbrella of Internet of Things. So what you see on the screen is something that I'm not going to go through in detail, but if anybody wants a copy of this, more than happy to share it. It's based on a white paper that has been published, not by me, but by an industry vendor. But it's really nice how it articulates the different capabilities and how we can look at the weaknesses and the points where we can improve the cybersecurity and trust of IoT. So what we can do here is take one pillar. So for things, we have the ownership and control. We have the capabilities, the functions that the IoT device will be doing, the connectivity for the IoT device, and then whether it's generally under sensing or actuating. So if we take connectivity, for example, what can you do to improve the trust? So connectivity, we have a ton of communication protocols to support IoT devices. There are more common protocols than others, like MQTT, HTTPS, CoAP, some in the more industrial settings. But in all, can we apply encryption? That's a question that's tricky because encryption, you have quantum-safe encryption, you have traditional encryption, you have devices with limited resources, you have latency-sensitive applications. Can you apply encryption? What encryption can you apply? Can devices support the encryption, etc.? So things and how to secure things across those dimensions. Then you have the data, and the data is where most of the decision-making is done. So you have what is the data that we're collecting? Is it structured, not structured, analog, digital? And how do we build trust frameworks around the data? What are the possible threat vectors that go against the data, like poisoning, etc.? Then you have the data V's, the velocity, volatility, and volume integration. How are the data flows integrated with the overall system? What are the points of integration? And you can continue with that. Then the last layer, which is the most important layer, are the insights, which contributes to whether insights or findings outside of the model or decision-making that goes into the closed loop. That's part of the automation. And then again, you see here some of the threats, some of the defense mechanisms, and we can go to that in the question and answer part of this panel. So with that, I'll pause and I'll give it over to the next panelist.
Eman, thank you so much. Very informative presentation. I always try to take some key takeaways from your presentation. And one of the things that I got was like scale. You talked about such a scale. And it's not just data anymore, but billions of IoT devices, and that's incredible. The other thing to think about is the use of AI now, and probably we can talk a little bit more too about large language models, but my takeaway too was resilience and reliability of AI models. So very good. Thank you so much. Next, I'd like to invite Dr. Belal Al-Sheikh Ali. He is a seasoned technical advisor and solutions advocate, excels in crafting cutting-edge cybersecurity solutions. Dr. Belal, please.
Yep, thank you, Kathy. Thank you, Dr. Eman, for the nice presentation. Can you see my screen? The most important question always.
Yes.
All right, because I have two screens, I need to make sure I'm sharing the correct one. All right, so yeah, my name is Belal Ali, and I'm working in the industry. I have been through the two sides of the fence, in the academia as well as in the industry. So currently I'm focusing on the industry. So most of the findings that I'm sharing today, it's related to actual gaps that we have found with our enterprise customers. Start the conversation with the IoT. I think Dr. Eman already, she paved the way for IoT. For us, IoT now, it's part of, let me put it this way. We have to face the critical reality. So all smart devices that we are dealing today with, it's not anymore at the edge. It's everywhere in our modern enterprises. And as you can see here, all the examples in the physical security, in the schools, in the hospitals. And just quickly, I would like to share one incident that I have been engaged with one private hospital, no names, of course, where actually, wherever you go to a hospital, I hope you don't, but you will find all these CTI scanners and X-rays, and you will find out even the operating system they are using still maybe Windows XP. So I'm not surprised, because the medical team, they don't care about the IT. And always they have the rule of thumb, if it works, don't shake the boat, keep it on. And this is where one of the medical guys, he just bought this CT scanner because it's running XP, it was expired, they need to get a patches, just expose it to the internet. And guess what? Hackers, they were waiting for such opportunity, excuse me, to attack the hospital. And eventually, what happened? The hospital was hit by a ransomware attack, and all operation for hospital was halted for 3 consecutive days. And just last week, what happened? This is personally with me. My wife, she was asking me, "Hey, Belal, now there is something called robot vacuum, Actually, I like the idea. So I have bought one. So when we started it up, it starts scanning the home, so it can build the map. So it has a camera, it has a sensors, and of course it's connected to the internet. So I was wondering, what else it's captured at my home except doing this, all the magic for mapping? And all these concerns, you can think about everything at home. Even now, coffee machines are smart. Even now, your TV is a smart TV, and it's connected to the internet. So anything connected to the internet, it's risky, and it is an entry point for for attackers. And this is actually takes us here. I don't need to scare you, but these actually all facts, and I have included the resource below from Palo Alto. What we call it here, security blind spot. Mainly, this is actually the security gaps currently available with IoT devices. And I would like to share with you another, I like this story because the first IoT incident that had been recorded in the industry, it was back in 2016. And it happens in a casino. And guess what? How the hackers, they were able to attack the casino. And of course, once we are talking about casino, you can imagine the confidentiality of data over there and amount of money. They attacked the thermometer for the fish tank because it is connected to the network and somehow it was exposed to the internet. So from the fish tank, they penetrate the network and they exfiltrate 10 gig of data. You can imagine 10 gig of data for casino. And that's actually, I think it was an eye-opener. Now we need to take IoT security seriously, as we do with all IT-related solutions, like our desktops, about our laptops, about our even personal devices. And I will take one more use case, which is related to IP cameras, CCTVs. So what we have seen here, there is a company called Verkada. And these guys, Verkada cameras, you can imagine 150,000 CCTV cameras had been exposed. And that's affecting Tesla, Nissan, school, hospitals, and hilariously, jails as well. So here you can imagine, I will share the slides later on, so we cannot go through the details due to the time constraint. But now there is a question. As long as all those IoT connected devices present an entry point for hackers and attackers, what we can do about it? So let's face it, IoT devices now, we agreed, they present a unique challenges. And we can tell they are the weakest link in the chain. And of course, Dr. Eman, she already touched a couple of vulnerabilities related to IoT devices. And the most common three ones here, it's about unpatched operating system. They have limited resources, which means we cannot install any kind of agents for a protection, for firewalling. Excuse me. And also the default passwords. You can imagine now there are free websites, free services, that you can just go there and you can give them the vendor name and they can scan the internet for any device connected to the internet with a default password. And that's also because if we are talking about one IT, and this is the majority of the society, not everyone is IT pro, right? So sometimes they just leave the default passwords. And again, default passwords by itself, it's a vulnerability and could be an entry point. So implementing zero trust principles, we see it is the effective way to secure the IoT environments. But again, it requires specific, I would say, technical capabilities as well as network readiness to move on, especially with unmanaged devices. And always, wherever I go to my customers, I challenge them with just one simple question. If you are students or you are an employee, you can just go to your IT. Ask them, when was the last time you have checked, even at home, your printer driver? Is the firmware is up to date? Is it vulnerable or not? Because again, printer is an IoT device by itself. But there is here a question. What is zero trust? So we are talking about zero trust principles would help us with IoT environment. So thanks for NIST, because the NIST special publication 800-207, they are thoroughly outlines all the principles to architect a zero trust, which is mainly it's a modern cybersecurity paradigm shift that assume no implicit trust at network location. Doesn't mean that you are an employee, you are trusted. I am at home and I have access over my TV or my smart fridge or smart coffee machine. Those are trusted. So if zero trust, it has a motto, it would be never trust, always verify. And this is where we need to make sure that all IoT connected devices, they are protected, and we do continuous scanning, continuous inspection for the traffic, for any abnormal behavior or abnormal connections. And what we have seen with one of my customers, I'm focusing mainly on the FSI banking, which is one of the critical infrastructure in the industry. We have found out that one of the C-level, of course, always in their offices, they have the big TV. And most probably they are putting, all this CNN and BBC business following the stock market. We have found that this IPTV has a channel to Russia. And I asked the question, is it authorized channel? Why a TV would have an open channel to Russia? What kind of traffic had been sent or been received? And that was, again, an eye-opener that, yes, we have to take IoT security seriously. And it's not just one-time solution or a product. So this is actually, I like this image on the right side. Zero trust is not a product. It's a strategy. It's about mind shift. How we should assume everything connected to the network is vulnerable and is an entry point for attackers and hackers. And that's what leads me now, moving from the industry to the academia, to focus on how I can build an IoT zero trust framework. So hopefully my paper will see the lights very soon. And here we assume that in order to simplify it for any organization to adopt the approach, if you see the value, so we have this matrix here. And we have 4 pillars for zero trust, tailored for IoT. So one, we have the identity, we have the device and workload, we have the access, and we have the transaction. Starting with identity. So it's about the identity, it's all about how we can validate the IoT with a strong authentication. So IoT device, if it has authentication capability, it should be authenticated. All right, and this is require a unique verifiable identity before any device allowed to communicate. And again, IoT here, it's not about small sensors using RFID or Zigbee or Bluetooth. We are talking about IP-based connected device, right? So this goes beyond simple IP addresses and often involves a digital certificate or hardware-based identification. Secondly, we have the device or the workload. We need to verify the IoT device integrity, because maybe one of the employees unintentionally bring a rogue device just to plug it to the network, right? Maybe this device doing scanning, I don't know, collecting information, doing spanning for the traffic, so they can take copy of the traffic. Because again, there is now another threat is it's a trending, which is called quantum security. So it is harvest now, decrypt later. So you need to have a mechanism to collect data, and the IoT device could be that potential sensor to collect the data. So we need to validate the integrity of the device and make sure it is connected to the right subnet within your environment that you have planned to, and you monitor the behavior. Remember, the IPTV has a channel to Russia. So this is abnormal behavior. So we need to have a mechanism in place that can detect and prevent such anomalies. And the third point here is the access. How we can enforce the least privileged access for data and application. If I have a fridge, I need to make smart fridge. Of course, everyone has a fridge. If we have a smart fridge, for instance, how we can validate it has only the required communication minimum to be precise, minimum required connections to do its job. And this is, by the way, applicable for us as a user. If I'm a student, I will have limited admin access, for example, to servers and to application, or I should have zero access. But if I'm a network admin, IT admin, I should have full access. So this is how we can enforce the least privilege. Once we identify those devices, we authenticate them, then we need to enforce the least privilege. Last but not least, it's about the transaction. So we have to continuously scan all the content for malicious activity and data theft. And this is how it happens. As long as there is a communication, a new communication established from the IoT devices, whether it is within the LAN, which we call it intranet, or over the internet, we have to scan it. And we need to scan the content for any malicious, maybe could be used in order, like it's a command and control channel, and it's been used to weaponize the IoT devices. As Dr. Eman mentioned with Mirai botnet, this is exactly what happened. And eventually, we have what we call it in our paper, the foundational enablers. So the entire framework is supported by a set of essential capability shown at the bottom of the image. So one, we need to have visibility and analytics. And let's face it, if you are you are in the security world, cybersecurity world, there is 101 rule. I would call it the golden rule of thumb. If you cannot see it, you cannot protect it. So this is why we need to have visibility on the IoT connected devices. Then we can apply our analytics engine. Secondly, we need to do a proper network segmentation, because what we have seen, especially now, we are focusing in this slides in the enterprise IoT, but you can imagine with OT environment. If we are talking about factory, we are talking about robotics, we are talking about oil and gas rigs and refineries. So we need to segregate IT network from the IoT/OT network. And then we need to enforce policy, which means we need to have a policy enforcement. We need to have a certain security control that enforces, remember, we discussed the least privilege, how we can enforce it. So we need to have enforcement point. And also we need to have asset management. So we can avoid having rogue devices connected to our network. So we can have inventory for all IP connected devices, IoT connected devices, and we can tell if they are connected to the right VLAN, right subnets, and they have the right privilege that it's supposed to have. And that leads us to the $1 million question, how to begin. So whenever I go to my customers, they say, oh, Belal, lovely. Actually, it sounds great on the slides, but how we begin? Of course, I hope there is a magic stick that, tick, we are zero trust compliant, because we agree there is nothing like that. And it's not a product, it's about journey. And the journey always starts with a step. So this is why here we came up with this 5-step journey for zero trust. All right. So step one, maybe I'm going beyond the time, so I will go fast now. But first step, it's about we have to define our crown jewels. What are the assets that matters the most for us within our environment? And once we define those, then we can go with the map the transaction. Okay, those devices that, again, for example, IPTV is my top asset. What are the transaction flow, which means traffic mapping? This IPTV should talk to whom, which region? We need to apply geolocation restriction if needed, because I know for a fact my IPTV will never, ever talk beyond, for example, to Russia or to China for whatever reasons, because we don't have any business with those guys. And then we architect the zero trust network in terms of zones and in terms of understand the impact. And this leads us to the risk assessment that Dr. Eman has talked about. And then we create the zero trust policy. And this is where enforcement point come into the play. So we need to apply least privilege, we need to have the visibility, and also we need to apply the policy based on layer 7, which means on the application layer rather than IP address and port, which is mainly layer 4. So we need to elevate the policy up to the layer 7. And of course, to close the loop, if you cannot measure it, you cannot improve it. And this is where monitor and maintain comes into play, because we agreed zero trust is about continuous verification. Don't trust, always verify. Of course, here, this is now, I would say, this is the methodology deep dive. I will not go through the details, but I'm happy to take any questions. I'll be staying here during the call for any questions. I can answer it on the Q&A or in the chat, but you can consider this is like about the conclusion and the future direction, you know, for fellows in academia, or if you are in the industry and you would like to adopt the zero trust mentality. So here we have two takeaways from this methodology. One, the framework aims to establish a resilient and scalable security posture, okay, tailored for IoT specific challenges that we have presented, focusing on the IoT security gaps. Also, we call them, remember, the blind spots, and explore how we can mitigate risk. Secondly, we need to automate and use machine learning, and this is especially for fellows in the academia. This is where you need, I think, to steer your focus, how we can leverage machine learning and the AI capabilities to identify critical enablers to scale zero trust implementation, especially in the dynamic IoT environments. Here to recap what we have discussed. So if I have 4 giveaways, this would be the 4 giveaways for you. We have discussed the IoT devices. We already realized it's coming, it's growing. We have to accept the fact. It's all about, as the defenders, how we can eliminate the risk associated with those IoT devices. I see it along with a lot of pros of zero trust. We say zero trust as a concept would help us to implement the right security measures to protect our environments, especially related to IoT environments against attacks. And we have, as we have seen, a lot of security gaps that should be filled. Maybe if you are in the academia, you need to focus in how you can build light algorithms for trust calculations. And again, I think point 4, it is related to that IoT devices, they are the weakest link in the chain. It's not anymore about the human being. It's not about my IT devices. It's all about the IoT connected devices. I'm sorry if I have been beyond my allocated time, and that's conclude my presentation for today.
Belal, no, what you shared now was fantastic, and you really captured all the key takeaways in your conclusion. A couple things that made me think was autonomous systems. We are so dependent now on them. I saw that you had talked about like Tesla, Nissan, um, even like a Tesla vehicle. Oh my goodness, there are so many different smart devices, IoT devices, sensors. It kind of makes me worried that
Yep.
is the Tesla like going to take over, or right? You know, the human versus the machine, as you talked about. And then the last thing was my takeaway from your presentation was this is a journey, the zero trust in IoT. So thank you so much. I'd
Sure.
like to, thank you. I'd like to invite Faud Khan to come next. And he is the CTO and co-founder of Sprig Learning. He is an industry veteran with more than 25 years of software development and cybersecurity experience. Faud?
Hi, everyone. Thank you, Kathy. Thank you, fellow panelists. Hopefully you can see my screen. just going to get into presentation mode. Hopefully you're still seeing it. I'm going to be quick because I want to make sure that we have time for questions at the end. So a big part of what I'm presenting around today is, what is the standards perspective? So we've seen how attacks are happening. We know how products are being created. A big part of this is, so how do we fix this, right? And so standards have definitely proven as a mechanism to do this. First and foremost, I think what you need to understand is any technology, we can't standardize it till that technology gets to a certain level of maturity, right? We've seen that before. When we first tried to do that for things like cloud computing, it turned out to be a bit of a disaster, right? Took a very long time because the technology wasn't at a point of maturity where we could actually look at what aspects we could standardize. So that was an issue. So we learned that, right? So IoT's been around for a long time. Now, we started seeing the attacks. Some of the previous presenters kind of touched on some of these and where they've been maturing, right? Because technology has been maturing with the uptake of AI and other things. But basically what's happening now is we're seeing that, government and industry players were getting nervous. And this is like 10 years ago. And so what we started to do at that point in ISO was Subcommittee 27, which deals with cybersecurity. You probably know of our group because we've created the standards for 27001, which is probably the most famous one. And then others for crypto, for common criteria, and others. Working Group 4, which I am the convener for, works on what are called security controls and services. So we basically deal with just about everything else, right? And IoT is a big part of that because it's technically a service, but then it's used as an interplay between other technologies. And basically, when we started to look at what we call a study period, right? So we created this study period years ago, and we started to look at, okay, what were some of the big factors, right? So we knew awareness was an issue. We knew lack of skills was an issue. And also, what were the requirements? And then with no baselines back then, it was really tough for the market to really understand. So, but we knew, like, if you basically start to look at this from a layer perspective, so if you put your almost engineering hat on, you can start to put things into where were they? And this diagram is basically a step back about 10 years, 10 or 15 years. And we said, okay, well, what is IoT? But IoT started to become a culmination of different technologies. And for those individual technologies, we actually understood how things were being attacked. We knew what the risks were, and we knew the result of, say, bad design or bad coding or bad implementation was causing these, right? And so from a device layer, we knew kind of what was going to exist, okay? From an application layer, we also knew what existed. And then from a network layer, we already knew. These were already attacks that were going on with other technologies that were being used by all kinds of different sectors. So the next question was, how do we then move towards addressing these issues? So this led to two works that are just, I guess, more recently have been published. So the first one was 27400. Okay, now this was the guideline for security and privacy, and I was fortunate to be the project lead on this project. And a big thing that happened at that time was, again, lots of countries were very involved with this whole thing. And like the UK had already kind of come up with this framework that they had. Etsy had a framework that they had. NIST also had different frameworks. So it was trying to build all these pieces together to basically create something that could be used across all sectors globally. And so with that, this was basically a means to start to create, okay, what do you need to consider? Okay. And that was basically our starting point. Now, shortly after we started this project, we started to kick off project 27402. So likewise, what this was the device baseline requirements, and this was published in 2023. For this project, again, I was a co-editor for it. And with it, though, really what we were able to do was really focus on what are those things that you need to do from a risk perspective, right? And Dr. Eman has already touched on this. That starts with a risk assessment. So you can't really basically mitigate the exposure of a device till you actually understand, what are the risks inherent to that deployment and use case. So that's where these helped in. Now, just these are not the only two standards. These are the only two I'm focusing on today. There are a host of other standards that you need to possibly consider, as well as the work that's being done in Subcommittee 4041 that deals with IoT. Now, they don't focus on the security aspects. They're most on the IoT kind of aspects, but they work with SC27 to make sure the security aspects are being considered in the standards that they're creating. So in case you didn't know that, hopefully that helps you expand into that. So what are some of the goals? Okay. So first and foremost, we need to be harmonized, right? In our group, we always try to make sure that we're working with what are called liaisons. So different groups, whether those are industry groups, whether those are specific governments that are there that have an interest in these topic areas. Basically, by harmonizing it, we basically are trying to reduce the overhead that any vendor is going to have to basically putting or implementing those controls and those risk management procedures into their organization. That's first and foremost. Two, it basically prevents barriers from being created for products getting into certain jurisdictions. So we've got to do that, right? It just makes sense. From the standards, by creating them horizontally too, what we can see is that we're taking a broader view of all of those different technologies that are now part of it, right? Because here's what we see is, in a lot of these, the products are not secure. So what do we have to do? We basically have created the security product industry because no one creates secure products or even software. So what do we have to do? We have to find ways to put stuff on. We have to put firewalls on networks. We have to put antivirus systems on. We have to put IDS on. We've got to put all these other pieces on because the core products and the software we're using are not secure, right? So it's this really weird dichotomy that we've created for ourselves in the entire sector where, if we just created secure products or we just created secure software, it would reduce the overhead for all of these additional tools we need to pile onto the network from an administration, organization perspective, and just risk management perspective. So I'll leave that there. And my last point is just around digital twins, right? And so digital twins is really what takes IoT to the next level, because all of those physical devices, which everyone just kind of automatically jumps into and considers as IoT, are now becoming software only. So that is really starting to explode from that perspective, where you can now create software componentry that is basically IoT componentry, and you can put it everywhere. And that's where you now get into these bigger system of systems. And we talked about the smart cars. Those are just one, but there's like countless others where we're seeing that, right? And you're definitely seeing this in more smart city deployments around the world. And so digital twins will definitely be the next facet into that. And I'm just going to leave it there for now. Just my contact details in case you want to get in touch with me. It's going to be in the video, so you can probably just rewind and look at that. But I'm just going to stop it there. And then, Kathy, I'm going to turn it back to you so we have enough time for some questions.
Thank you very much, Faud. Very interesting presentation. And I liked how you touched on digital twins at the very end. I know digital twins technology is really advancing more and more. And one of the things I always wonder about is the physical versus the cyber, right? Virtual worlds, and how can you tell the difference? So
You
I'd
can't.
like to...
From the user perspective, usually you can't, right? Because they just think they're interacting with the device, and they, a lot of times the whole idea of it is it's cheaper to get to market, and it's cheaper to do all kinds of stuff from testing and evaluation to monitoring. So yeah, definitely, it's a very interesting topic.
It is. I'd like to invite all of the panelists to turn their video on.
Yep, here we go.
Yep. Thank you all. And I have a question here from the attendees. One is from Hannah. What are your thoughts on the future of zero trust methodology in a hybrid and a multi-cloud environment?
Yeah, I can take this one.
All right.
Okay, so once we are talking about zero trust, as we agreed, it's a methodology, so it's not restricted to on-prem or to the cloud. And whatever we do in terms of the security controls now for on-prem, still we can apply it and we can span it to the cloud. So it's all about having the framework and make sure we enforce the right security policies and having the right security controls in place. So it doesn't matter where are your assets reside, where is the traffic flow is moving east-west within your data center or from everywhere to the cloud. You need to ensure, again, we have enforced the least privilege, we enforce inspection for all the traffic, and continuously inspect the traffic for any abnormalities.
Yeah, I'd like to connect. Correct, Bilal. But this a few things that we need to remember here. Most of these environments, especially if we start talking about hybrid and multi-cloud environments, if you are the tenant, yes, you have some control. If you're not the tenant and you're part of a process that expands across multiple tenancy, you don't have, unfortunately, the control. So what you can do is you can control your perimeter, and that's for your own zero trust security guarantees. But you have to be more stringent against what comes in and especially what comes in. So just to give you an analogy, if you build your house, the most secure house in a bad neighborhood, you don't have control over the neighborhood. You have control over your house. Does this eliminate the risk? Some of them, but you still have to monitor a lot. So zero trust has, in part of it, is monitor everything. So you have to maintain that awareness. But then you cannot monitor everything because in the cloud, you do not have that visibility. You have a limited visibility on what's going on behind your fences. And it depends on your deployment in the cloud. If you are infrastructure as a service or application as a service, etc. So there are some things that you need to think about when it comes to the specific question. So I like that.
Yeah. If I
Yeah.
can just also add on top of that, because I'm speaking from industry point of view, because we have now most of customers, they have projects. We have heard about digital transformation. Now we are hearing about cloudification, which means we are moving from on-prem to cloud, especially with multi-cloud. And this is where actually we can see leading vendors. I don't need to promote anyone because I'm working for one of them. There is something it's called the industry name CSPM, Cloud Security Posture Management. So I agree with you, we don't have control on the cloud itself, the cloud provider, the CSPs, but we do have control in our instances on the cloud. And especially if we are going with multi-cloud approach, we need to make sure we build a baseline, and if there is any, let's say, variation or any traffic or workload or malicious activity, we cannot say malicious, even suspicious activities. This is where the visibility and analytics should kick in. And again, of course, we cannot eliminate the human factor where they need to come in and they need to do their due diligence to investigate more and see that, oh, whatever this activities that we are suspicious about, it's legitimate one.
Yeah.
So
Yeah.
it's all about CSPM, it's a cloud security posture management, especially if we need to span zero trust to the cloud.
Yeah.
Okay. We are pretty much at the top of the hour, and what I'd like to do is invite each of the panelists to share one item that we as humans can do to contribute and practice zero trust. Okay.
I can start, yeah.
Eman?
Yeah, I can start. So it's a statement I use over and over again. It's everybody's responsibility. So if you are buying a software, don't go for the cheapest. Go for something that has cybersecurity built in. This is how you support vendors who respect you as an individual and they think that you deserve better security. Also, if you are an expert, participate in initiatives. I like how Faud and Belal are active. I'm active with IEEE. Wherever you can make an impact to push security forward, do that. If you are an engineer, similar to what Belal and Faud doing, in your role as an engineer building solutions for clients, or you are part of the engineering team on the client side, educate yourself on the security so that when you build a solution, it's part of your SLA, it's part of your KPIs. Don't just go for the de facto. We want to make something that works. No, we want to make something that's trustworthy and ensures the safety of all our stakeholders. So everybody's responsibility.
Thank you very much. Very well stated. Belal?
Yeah, actually, if I have an advice, it would be stay always extra vigilant about any potential threats, and within the zero trust, again, yeah, even it is IT related, never trust, always verify. You will never win iPhone 17 because you are lucky. You will never receive an email, someone has died and put your name on his will. It doesn't work like this. So always verify what you are receiving and stay extra vigilant once it comes to the cyber attacks.
Thank you. Faud?
Yeah, to just build on that, I would just say, don't be afraid to put vendors on the hot seat, right? Ask them the uncomfortable questions. If they're squirming in their seats, you know to look somewhere else, right? Because they don't have the answers and they're not doing the due diligence to secure their products. So that would be my big thing, is that's where you understand trust, right? Because trust is a two-way factor. A vendor does not dictate that, you do.
Yeah.
All right.
Thank
Thank
you.
you very much. With that, then, I want to thank my panelists. Excellent presentation and discussion. Please check back for when the recording is ready. And that concludes our webinar. Thank you so much, all.
Thank you.
Thank you, everyone.
Thanks. Have a good one.